Today we will solve some practical problems of alpha decay topic which we already discussed in our previous lecture. So today we will solve some of them numericals, like we will solve chapter number 3 problem number 12, 13 and 14 for the case of alpha decay. Okay, this will help you to understand this topic briefly. So let's start. So our first problem is basically you have to calculate the energy released by the alpha decay of radon, okay, which is 22286. Okay, so you have to calculate the energy released by the alpha particle decay of radon. So first of all, because this is an alpha particle decay, you already know. So you know that radon must decay into a polonium, because you can see in section C it says what is the energy of the recoil polonium atom. So it's understood that radium decays into the polonium because this is an alpha decay, so it also emits a alpha particle like helium atom. Okay, plus q, it also release some amount of energy. So how you can solve this? Let me show you. Here is my solution for you, how you can solve this. So you can say our a section, it shows that calculate the energy released by the alpha decay of radium. So first of all, you must have to know the relation that your radon is decaying into, okay, into different aspects you can see here. Okay, radon 22286 decays. So to find the q value, there is a formula. You already know that q value is basically equals to mass of radon minus mass of parent minus daughter. So parent is mass of radon and daughter is basically the output, basically the product is polonium and alpha particle. So minus mass of this into c square. So masses of all these are given. Okay, these always given to you. Okay, don't worry about that. Mass of radon atom in AMU and mass of polonium should be given to you. Okay, mass of alpha particle, you know that it's basically 0.004.0026. Okay, in AMU. So to convert AMU into mega electron volts, you have to multiply by c square, and the value of c square is basically is 931.5 mega electron volts per U. Okay, U cancels with this U and you will get your Q value in mega electron volts. So after calculating, after substituting this, you will get your final relation, and that is equals to 5.59. So this is the energy released by the alpha decay, okay, in mega electron volts. The B part is basically calculate the energy released of the alpha particle. Now we have to find E alpha. Basically the energy released by the specific only alpha particle. We know that here is we know the formula for E alpha is basically this. Okay, Q, which is the total energy released, we already find, multiplies by mass of alpha particle divided by mass of alpha particle plus mass of alpha particle, again mass of helium plus mass of polonium. So you know that the mass of the alpha particle is this 4, and q value we already find in mega electron volt, which is this put, and we know that the mass of alpha particle is basically 4. 4 plus mass of polonium is 218. 218 plus 4 becomes 222. Okay, so after substituting, you will get your final relation, and E alpha basically now equals to 0.1007 mega electron volts. So this is how you can find the energy released, okay, in alpha particle. Similarly, our last section for this part C is what is the energy of the recoil, okay, of the polonium. So we already know that our total energy, this Q, okay, total energy released must be always equals to the sum of the alpha release energy plus the recoil energy. Okay, because here your alpha decay conserve, okay, conserve momentum. To conserve momentum, your total energy release must be equals to sum of the alpha particle plus recoil. So this alpha particle here, so Q becomes equals to E recoil plus E alpha, but in that case you have to find E recoil. So E recoil must be equals to total energy minus E alpha. Total energy we already find, which is this, and E alpha we find here, and after substituting you will get your value of the energy of the recoil, and that is equals to 5.48393 mega electron volts. So this is how you can solve problem number 12. Okay. Now let's move towards the next problem number 13. What it says, the uranium 23892 nucleus emits a 4.20 mega electron volts alpha particle. Okay. Now the isotope 238 of uranium is decaying and emits an energy of 4.20 mega electron volts alpha particle. What is the total energy released in the decay? Now the alpha energy is given, that is 4.20, and you have to find the total energy. How you can find the total energy? Quite easy. Okay. Now move on towards the third. So to find total energy, there is a formula. We already know that as here. This is the formula of E alpha, but if you want to find Q means total energy, only move these multiply by E alpha divided by M alpha. So this here you can see. After taking LCM, it's this like equation. Okay. So to find the Q value, total energy released. Okay. So it must be equals to E alpha 1 plus M alpha divided by mass of the basically the product. You can say in our case, our uranium 238 decays first of all in therium TH, and with an emission of an alpha particle, and with plus Q because it also release some energy. Okay, so uranium 23892 first of all decays into therium 23490 to conserve charge masses. So with also it emits a helium alpha particle plus Q, which is the energy, and that is we have to find in this problem. So E alpha is already given and at 4.20 mega electron volts, and M alpha we already know mass of the alpha particle always 4.0026, and similarly mass of this is always given to you in your problems, and that is equals to 234.436. Okay, in AMU. After substituting, you will get your answer in mega electron volts, and your answer is basically 4.28 mega electron volts. This is the total energy. Okay, so that's all for this problem number 13. Now move towards the last problem of our this topic. Alpha decay is basically you can see here. Now your radium 22688 nucleus emits a 4.60 mega electron volts. Now radium is decaying with an emission of 4.60 mega electron volts and okay alpha particle 5.5 of its time when it decays into the okay radon 222. Basically now radium decays into the radon 222. So to conserve their mass number, it emits with it's going into radon plus it emits also helium alpha particle plus Q. Okay, what you have to find, again you have to first of all find the Q value of that decay. Okay, so let's start the how to find Q value. Again the formula is same. Okay, E alpha bracket 1 plus M alpha divided by, because now it decays into radon, so that's why your product is radon, so that's why we have to use mass of radon in denominator. Okay, so E alpha value is already given, that is 4.60 mega electron volts. Okay, and you can see here okay, after putting all the values, M alpha value and mass of radon is basically again AMU is basically 2.222.0175. In AMU, after calculating, you will get your final results in mega electron volts is basically 4.69 mega electron volts. Okay, so this is how you can find the Q value. Okay, now the second part of this problem is find the recoil energy. Okay, now here E alpha is given and Q we find here. So Q is here and E alpha we already given, so we can find easily the recoil energy because we know that the total energy Q must be equals to the sum of both. Okay, so what we have to do, we just have to do total energy is basically this 4.69, and we have to minus it with this energy okay, E alpha 4.60. After subtracting, you will get your final answer, and your recoil energy was 0.08. Okay, this is another formula how you can find, but directly you already know as we did here. Okay, you have to use this formula. Okay, to finding E recoil you have to minus your alpha energy by the total energy. So here is your alpha energy. You have to subtract this from this. After subtracting, you will get your final recoil energy, and that is equals to 0.01 0.0845 mega electron volts. So that's all for today. How you can solve relevant problems of alpha decay, the topic which we already discussed in our previous lecture. You can first go through that lecture, then you have to move towards these problems. Okay, so that's all for today. Keep watching and stay tuned with us. Thanks for watching. Allah Hafiz.